All right, so we're talking about steps to success, which is just a funny way of saying step functions, okay? Remember I told you when you did your parent function that, oh, we're gonna learn this function later? Here's the later of that greatest integer function in the step function. What the steps up here are so that when we graph it, it can look a certain way in the calculator for us that we're gonna follow. So first thing first is just making sure that you understand that there's the math button, and the math button here is just basically a list of general commands for your calculator. And that the commands here generate piecewise functions and other things as well. But we're going to be using 2 and 5 for this set of notes. So for our notes today, we're going to be using we'll be using 2 and 5 from the math number function. Okay. We're also going to change the settings of our calculator, the window settings, so that we can be in a perfect zoom window to see the difference. And then the other thing is we're going to change connected to dot. On your calculator, it's going to say thick dot or thin dot. I don't know why it says that now. It doesn't really matter which one it does, but excuse me. The people. So yours is going to say thick dot or thin dot because it's the newer calculator. I don't know why they switched it just from connected to dot to thick and thin dots, but choose thick for all I care. So I'm going to go through that with the calculator. So with my calculator, I'm going to change my window settings. I'm going to reset my calculator first because I was using it before this class. And now I'm going to go to window and I'm going to put in -4 and 7/10. I'm going to put in 4 7/10. I'm going to leave the 1. I'm going to put in -4. I'm going to put in +4, and I'm going to leave the last remaining ones. So that's what it means to change the window settings. The next thing it tells me to do is I'm going to press mode, and I'm going to change from connected to dot. And again, on mine, it's just dot. On yours, you're going to choose thick dot. I know it's really weird, but yeah. It's right here, sweetie. Yeah. The window settings are right there. Exactly what I did is written. Just read. Okay, so as far as that goes, that's all we've done so far in the calculator. Now we're going to begin graphing in the calculator because our calculator is set and ready for us to graph step functions, aka a type of piecewise. So the first one that we're going to graph, we're going to go to y equals, because that's how you graph from any screen. When you go to y equals, you should have dots instead of a solid line if you turned on the dot feature. Does that make sense? So I'm going to go to y equals, and notice how instead of having dot straight lines, it's now all dots. And now I'm going to go put in round. In order to get to round, remember, we said we have to remember the math, arrow over to number feature. So math, arrow over to number, and we're going to click on round. So I'm going to press math, right arrow, and I'm going to press 2 for round. Now I'm going to type in x, 0. I'm going to use my variable button, comma, 0, and close the parenthesis. Everything is in that second column, all the way down. The x, the variable button, the comma, the 0. Bless you. Okay. Now we want to graph. So I'm going to press graph, and it should graph the step function. It looks like actual steps, hence why it's called a step function. Okay. If you are not at this screen, please raise your hand if you need help, or if you're just not at the screen because you're working at your own pace. Okay. Okay, so once you have your graph, the thing that you can't see here is that this is our rounding function, okay? With the rounding function, on the left-hand side, these are closed circle, and on the right-hand side, they are closed, yeah. On the left hand, they're closed. On the right hand, they are open. You can't see it because the calculator can only do so much. Does that make sense? So it's part of you having the knowledge of it. So when you're creating your graph here, you're thinking about this. If I want a number to round to 0, in order for a number to round to 0, it has to be what? Between negative 0.5 and positive 0.5, right? So essentially for this, well, on this, I'm sorry, these are both open circles. I said closed, except they're wrong. Yeah, open, closed. Yeah, we'll see. So at 0, we're gonna have an open circle at negative 0.5 and an open circle at positive 0.5. So it looks like, I'm gonna zoom in so I can draw better, hopefully. It's really hard for me to draw, guys. So that's an open. Can you tell that it's open? Oh man, I tried. It looks closed. Okay. All right, let me try again. Does that look open? Okay. So these are both open. Are y'all with me? So the only one that has 2 open circles is at 0. So at 0, we have 2 open circles. That's because in order to round to 0, we have to be between negative 0.5 and positive 0.5. But I didn't say equal to, right? We're strictly in between. Any number in between those, right? Okay. So now, when I want to be at 1, I can equal 0.5, but I have to be less than 1.5. Does that make sense? Mm-hmm. And then this pattern will continue. So if I want to equal 2, I can equal 2, but at 2.5, I have to be less than. Okay? If I want to equal 3, at 2.5, I equal 3, but up until 3.5, I have to be less than. Are y'all still with me? I am. It's a pattern. Okay, and then we keep going. It's a step pattern. And there we go. Oh, that one does not look. It is you. Nice one, I bet. All right, and then I'm going to do it on the bottom. So down here. So here, if I want to be negative 1, I have to equal at negative 0.5, right? I have to equal at negative 0.5, but at negative 1.5, I'm open. And then we're going to continue, same pattern. Continue, same pattern. All right. That was really hard to do, but that's where the steps are. Now, the calculator itself can only tell us so much. Does that make sense? Mm-hmm. So you have to use a little bit of math sense to understand where the open and closed circles take place. Okay? So let me zoom out. Now, when I zoom out, hopefully they still look open. So when I'm using my graph, if I go to 1.5, so if I go to 1.5, then 1.4, I'm sorry, and I go up, what line does it fall on? It falls on 1. So what is the answer here? 1. With me? If I go to 1.5, this is an open one, so I can't use it. So the closed one's at what? 2. So the value of 1.5 is 2. If I go to 2, it falls where? On 2. If I go to 2.7, it falls on 3. And that's because what is this function doing? Stepping. It's stepping, but it's rounding. It's rounding to the nearest 10. Your 10 up to the nearest whole. Does that make sense? So that's what you're going to put in your own words right here is describe what is the graph doing. So what did the function do? I want you in your own words, tell me, or tell yourself, because these are your notes. What did we see and what did we analyze happening? So whether you're writing it rounded from the tens place, or remembering your rules, if there's a 5, 6, 7, 8, 9 in the tens place, what does it do to the ones place? Okay, so we're gonna write the intervals of when this happens. So for 1, so looking at our graph, to get the value of 1, where does it start and where does it end? 0.5. So at 0.5, but then at is less than. Do we see that? Okay. And then if I want to have 2, what do we get? Are we cool with the pattern so far? Who said no?
I'm kidding.
Oh. And then therefore 3 would be? Less than what? Sorry, it's 3.1. I forgot my 5. I was like, wait, I missed something there. All right. Yes. How do you feel about the rounding step function?
Great, amazing. Wonderful. Fantastic.
Huh?
Yeah.
All right. So now we're going to look at the greatest integer function, which is what you had to do your project over, right? So how did that look? In the calculator, we're not going to change our settings. We're just going to change our y1. So in y1, we're now going to put int x. So to get the greatest integer function, you're going to go back to math over the number, but this time we're going to use 5. Do you see int at 5? And then I'm going to put in my x and close it. Okay. Now, when my calculator, I don't know if the updated calculator, if y'all does it or not, but no matter what, on my calculator, it's just so outdated, it's going to actually look like stairs. On mine, like legit looks like stairs. I think y'all just update it and it doesn't look like stairs, but good old faithful here is gonna make stairs still. So
Good old
Clear.
is hands and pencil.
so do we? And I also have my brain, so I know that. Are they actually connected like this? No, they are not. Okay. So therefore, I would not graph it like that, obviously. We're going to talk about the greatest integer function. Okay. On your greatest integer function, let me try zooming in again. Oh, whoa, not that far. So on your greatest integer function, when you did it, what did you notice about the graph on your project? What did it do? Greatest integer? No one can tell me what the graph looked like. What was happening with the graph?
Oh, it's like steps.
It's steps. And where did it start? Okay, at the origin. At the origin, is it an open or a closed circle?
It is open.
It was closed.
Oh.
It should have been closed. Guys.
Oh,
It should have been
maybe I
closed.
should do-
Okay, it should have been closed, and then the first step goes out to 0, from 0 to 1.
Oh, I didn't write on this paper, but I don't know why I said open on there.
Okay.
I got
And then it
paper.
continue
Yeah, me too. How did you-
like this, right? I hope so.
Uh-huh.
If your project did not look like this, then you know that this is one graph you got wrong.
Oh, damn. Can I get it?
So I'm just giving you that heads up there. And if it did not look like this, you did something wrong.
So I was gonna say I'm gonna come to the tutorials on Friday, but I realized
We don't. All right.
I
So
have
with the greatest integer, how it works is that no matter what it is, it's just going to be whatever that integer is, that 0 is, right? So even if I had 1.5, it's still just gonna be 1, right? 1.6 is still gonna be 1. 1.7 is still gonna be 1. That's how the greatest integer function works, okay? So here, 1.4, 1, 1.5, 2, 2.7, 2. That's how the greatest integer function works, right? And you can double check it by looking at your graph. If I go to 1.5 on the x-axis and I follow it up, what line do I land on? 1. If I go to 2.7 and I follow it up, what line do I land on? 2. Okay, so that's how that works. So in your own words, you're going to explain that. And now we're going to write our integer example. So -1. If I want to get the value of -1 from what to what? Bless you. There we go. -1. X is greater than or equal to -1, but less than 0. Agree? Okay. What about if I want to get the value of 0? Where was that at? Okay. What if I wanted to get 1? Perfect. And then what if I wanted to get 2? And those would be your intervals. Okay. If it felt like he was going fast, that means you don't understand what we're doing. So ask me a question.
No, it's you were writing fast.
No. You should be able to write it without me. So tell me why you couldn't do it without me.
I don't know why. I don't know.
Do you understand where he got that from?
Mostly. I
So,
can't think of a question. If I
so
come
where's
up with a
5?
question,
Where's 5? If I want to get the value of 5, what would my interval be?
5,
If I wanted the value 5,
6,
what would my interval be?
5 is less than or equal to x less than
6.
6.
So why did you need me to slow down?
What's up?
Just verifying. Okay. All right. Here we go. We're gonna talk about word problems. With the word problem, we're gonna kind of sketch and describe what's happening here. Okay. It said the scale in the bathroom only shows weights to the nearest pound. This means that if an object weighs less than 1/2 of a pound, the scale will show it as 0. But if something weighs 4.48 pounds, the scale will record it as 4. Okay. So sketch a graph. So we know that you're going to get 0 if you are what? Less than 1/2 a pound. So it's 0 here up until 1/2 a pound. And boom. Does that make sense?
So, it's like pattern and everything.
Exactly. Once you start it, you should see the pattern. That's the hope, right? Okay. So if I weigh 0.5, what is the scale going to show?
With 0.5 is
It's going to show a 1, right? Does that make sense? And if I weigh 1.5, will it show 1 also?
Yes.
Or will it just show 1?
1.
Will it say 1 point? I said, will it say 1.5? Will it show 1 or will it show 2?
No, it's
It'll show 2. So here at 1.5, it's going to be open, but at 2, it's going to be closed. So I'm going to continue. Is that okay if I do it without saying it out loud? Okay, I don't want to draw it all the way to the top, so we get it, right? All right, so based on our graph, is this a rounding function or a greatest integer function? It's a rounding. Nope, just gotta tell me whether it's greatest integer or rounding. How do you feel about creating the graph? Okay, we're gonna do one more. It says a payphone charges by the minute or each part of a minute. That means you'll be charged for 1 minute for calls of only a few seconds. Also, if a person talks for 2.2 minutes, she will still be charged for 3 minutes. Okay, so it's saying, yes, at 0, I'm not going to charge you, right? But as soon as you go past 0, I'm charging you how much? A whole $1, right? So at 0, it's not $1, but anything past 0 up until 1 is going to be a $1. Yeah. And then after 1, no matter how long you talk, it's going to be $2. And then if you're after 2 minutes, it's going to be $3. After 3 minutes, it's going to be $4. After 4, do we see the pattern? Okay. Which one does this one more closely relate to? Interval. It relates to the greatest integer, not interval. Integer. So this would be more of the greatest integer section, right?
Wait. Why is the 3, is that open? The first one?
Which one?
The first dot.
The first dot, it should be.
Okay.
This one?
No, first one.
So, the first dot, no.
Oh yeah, that's open. It just got weird. Okay. All right. How do we feel? So on your homework, you're going to be creating 7 graphs. So there should have been graph paper that you need to grab. So the first 3 graphs are just practicing graphing a basic step function, okay? So it's just practicing basic step function. I'm gonna have a segment from -2 to 0, 3 to 1, 0 to 2, right? So those are your first 3 graphs, are pretty basic. Questions about 1, 2, 3. Okay, now you guys are very quick to tell me, Miss, you did not do an example like that in the notes, and I cannot do it. Okay, I made every single one of your problems about a phone call. Yeah, they're all about a phone call. So nice try today. So apparently, because if I go away from any other example, we freak out. Okay. It's okay. All right. So, you're not the first, Daniel. You won't be the last. So, okay. So here on number 4, it says, suppose that it costs 50 cents. 50 cents for the first minute of a long distance telephone call and 20 cents for each additional minute or fraction thereof. Okay. Give a graphical model of the cost of the call lasts 15 minutes. So on the table, it tells you if you talk for more than 0 minutes, but less than 1 minute, you're going to pay how much? 50 cents, right? And then every time you go up, every extra minute you add on there, it's going to charge you 20 cents, right? So if I was to continue this table, you hopefully can continue it without me, right? Yeah. Yeah. 90. Okay. And now you're going to, from this table of information, you're going to create the graph and create a piecewise that explains it. Okay. Where does it start? Where does it end? What are your values? Okay. On the back, the only one that is not about the phone call are the parking, but hopefully it'll be fine once you get to the parking. Our next one here is about another phone call, and it's just talk about the additional after. So you're going to write your function, draw the graph, and that'll be it. Okay. I would, if you need to start off with the table, if you need to break it down for yourself, that's fine. It says here it costs $1.40 for the first minute of a phone call to pairs. And then it's going to be 80 cents for each additional minute or a fraction thereof, right? So as soon as I go past a minute, I now have to pay 80 cents, right? Then I go past another minute, I got to pay another 80 cents, another minute, another 80 cents, right? So you're following that. Now 6 and 7. Oh no, I am putting you in a car now. Okay. Oh no, we're in a car. Yeah. Is it going to change because I'm in a car? No, it is not, guys, okay? It'll be okay. You will survive. Okay. You already did 2 on the phone, okay? All right, so that is what you're doing. It'll be due Friday. Got it? All right, Friday.